Oh, yeah, the doctor's in the house, y'all. He's in the house, man. Let's listen to this man. He got some good news for you. Hey, everybody, gather near. The doctor's in the house, so lend him your ear. The things he can say might even make your day. He might even help your pain go away. The doctor is in the house. The doctor is in the house. Let the doctor know what's bothering you. I'm sure he can tell you just what to do. The doctor is in the house.
Oh, ladies and gentlemen, the doctor is in the house. Wow, what a welcome. Welcome, everybody. This is Dr. Ron, host of Dr. Ron, Unfiltered, Uncensored, bringing you episode number 645. And this is a follow-up to the prior episode 644 when we started to speak and learn about essential fatty acids, and especially linoleic acid, which is essential, which means your body cannot make it. So, ladies and gentlemen, if you have not signed up and subscribed to my Substack page, which is docronradio.substack.com, please do so. It's free, and you will have access to other podcasts and also summaries of the podcasts that you hear on Podbean. And if you want to subscribe at Podbean, it is also free, and that is docronradio.podbean.com. And you will get advance notice of my live broadcast where I can actually take some questions and when other podcasts are published. Enough about that, but thank you for tuning in today. And today, we're going to be talking about linoleic acid. Is it a nutrient or is it this time bomb that everybody's talking about? So we'll step into this controversial territory. Linoleic acid, omega-6, seed oils. This topic, depending on who you ask, it's either a heart-healthy essential nutrient or a metabolic disaster fueling inflammation and chronic disease. And both sides speak with certainty. Both cite studies. Both accuse the others of bias. So today we're going to slow this down a little bit. No slogans, no fear, just biochemistry. Because the real question is not, is linoleic acid good or bad? The real question is, what happens to linoleic acid in different biological contexts? I sort of gave you the answer last week when we talked about linoleic acid, whether it is oxidized or not, whether it is processed or not, whether it is adulterated or not. So what linoleic acid actually is, it's an 18-carbon polyunsaturated fatty acid. It means that it has bonds that are not tied to anything that could be oxidized. It is essential. We cannot synthesize it. Keep that in mind as we go further. Linoleic acid plays structural roles. It's in cell membranes. And as you will hear from the world expert on this subject, Professor Brian Peskin, it's not only in cell membranes. You have to remember the cell membranes are also part of the mitochondria, and we'll get into that also. So linoleic acid is in cell membranes, including the mitochondria, the skin, normal growth. It has to do with reproductive physiology. It's a precursor to arachidonic acid, which is involved in inflammatory signaling. and it is also in normal immune function. Now, keep this in mind. Inflammatory signaling is not inherently bad. In fact, I'll go out and say it is necessary. The body requires a balance of omega-6 and omega-3 fatty acids to regulate eicosanoid production. Now, here's where we get interesting. And this is based on what I said last week. When linoleic acid is consumed in whole foods, like nuts and seeds, it exists within a natural matrix. And it is accompanied by vitamin E, polyphenols, and antioxidants. And in that state, it is relatively stable. In that state, it is not automatically inflammatory. Large epidemiological studies often show neutral and even favorable cardiovascular associations when moderate amounts of linoleic acid replace refined carbohydrates or saturated fat. That's the essential nutrient story. And it's real, but it's not the whole story. The modern food system changed the whole context. Industrial seed oils, now these are processed. They're extracted at high temperatures. They're chemically refined. They are bleached and deodorized. They are stored for long periods of time. And in restaurants, they are repeatedly heated. Polyunsaturated fats are chemically fragile. 2 double bonds make linoleic acid highly prone to oxidation. They're those bonds that have nothing attached to them in nature. 2 double bonds. They can be oxidized, and when they get oxidized, they form lipid hyperperoxides, reactive aldehydes, oxidized linoleic acid metabolites. I mean, these are toxic to our body, and these compounds are biologically active. And why do I say they're toxic? Well, they can activate inflammatory pathways. They can modify our proteins. They can disrupt mitochondrial enzymes, and they can damage membranes, the phospholipids in the membranes. So now we have a different biochemical scenario. Same molecule, but is it oxidized or not? And this is the difference between unadulterated and adulterated linoleic acid. And you rarely hear this distinction with precision. Rarely is it ever discussed. And that's the important point. Is it adulterated or unadulterated? So let's talk a little bit about the mitochondria and the mitochondria membranes. The mitochondria rely on membrane integrity. The inner mitochondrial membrane contains a unique phospholipid called cardiolipin. Cardiolipin anchors electron transport chain complexes. It is essential for efficient ATP production. ATP is the energy production. You know, as I said last week, people feel fatigued and brain fog. They're not producing enough ATP. Cardiolipin, remember, that's one of the layers of the mitochondria. Cardiolipin is highly susceptible to oxidative damage. And when you get some of these adulterated linoleic acid in your system, when the lipid peroxidation increases, electron transport chains efficiency declines, proton gradients destabilize, reactive oxygen species increase, and ATP, the most important part, falls. Your energy level falls off the roof. And it doesn't require catastrophic damage. It's subtle inefficiencies. You don't even know what's going on in your cells, but you know your exercise tolerance is affected. You don't recover as fast. You have brain fog. You have chronic fatigue. Now, this does not mean that linoleic acid automatically causes mitochondrial failure. It means in an already inflamed, stressed system, highly oxidizable lipids may increase your vulnerability. The oxidized, the adulterated lipids. Context matters, ladies and gentlemen. Metabolic health matters. antioxidant capacity matters. Dose matters, and importantly, processing matters. Unadulterated versus adulterated. So what about research? Well, there's epidemiological data that show that moderate linoleic acid intake is generally not associated with increased systemic inflammation markers. How about that? In many studies, I could say, cohort studies, replacing saturated fat with polyunsaturated fat lowers LDL cholesterol and reduces cardiovascular events. You can't ignore that evidence. At the same time, you have what's called mechanistic studies. They're the studies that drill down into the cell, that look at the fire, but they don't look at the whole picture. But mechanistic studies show that oxidized linoleic acid metabolites promote oxidative stress and inflammatory signaling. Remember, I said the cohort studies, which look at correlations between what is happening and what is it being ingested, versus mechanistic studies, which drill down further. They show that oxidized linoleic acid promotes inflammation. Animal models demonstrate increased lipid peroxidation under high polyunsaturated fatty acid diets, especially when you don't have enough antioxidants. So both bodies of study are valid. The ones that show that LA is anti-inflammatory and one that shows LA is inflammatory. But there's a conflict, right? And the conflict arises because most population studies do not distinguish between oxidized and non-oxidized intake. And the mechanistic models often exaggerate exposure beyond typical human intake. Here we have a little confirmational bias. If you want LA to be the villain, you can find studies to support that. If you want LA to be protective, you can find studies that support that. But biology is not binary. And for those of you that have followed Professor Peskin on my podcast and on his website, and he will be my guest on a giant Zoom meeting March 24th. He'll explain it more than I can. He's lived this in this life for 25, 30 years. He understands the difference between oxidized and unoxidized. And you can find studies on either side, but we have to go down to the cellular level and see what's really happening. See where linoleic acid really does its work. Do we want to look at animal models? Do we want to look at glass in vitro models? It matters. So linoleic acid, you can find pros and cons. But I will tell you that Professor Peskin's view is that the adulterated linoleic acid is toxic and inflammatory. And he's actually developed some therapies using what he has termed parent essential oils to correct those cell membranes that become toxic. So what is a rational position? Well, I'll tell you, my position is linoleic acid is essential. Whole food sources are not inherently harmful. They're whole food, unprocessed. However, once you have ultra-processed food, repeatedly heating oils, deep frying commercial products, long-stored refined seed oils, that's how you get increased exposure to the oxidized lipid products, and oxidized lipids in metabolically stressed systems contribute to inflammation. Okay, again, it's that distinction. So we always have to look at the context. So what should we do? Reduce ultra-processed foods. That's a given because of all the other side effects of processing food. We have to avoid repeatedly heating commercial frying oils. In other words, you have to go to restaurants or start cooking in to avoid this problem. You have to keep your own antioxidant defenses strong through eating whole foods. And we have to fix the underlying inflammatory drivers. This is where sometimes supplements are really important. And looking forward to hearing Professor Peskins. I know the answer because we've discussed it. He has a product that can do that. Linoleic acid is not a toxin. It's not a miracle. It is biologically active. It is a biologically active molecule whose behavior depends on the environment. We have to understand the context. When we do, we gain clarity. So the enemy is not a single fatty acid. It is metabolic stress. Metabolic stress. When you have that and you have oxidized or adulterated linoleic acid, you will have consequences. So I would ask you, ladies and gentlemen, to subscribe to my Substack page where I will post a link to a Zoom conference where I will have as a guest Professor Peskin. And we may have to do 2 hours. I don't know. We'll do 1 hour for sure on March 24th. And we will not filter the truth. We'll only amplify it during the seminar. So thank you for tuning in. And I know this is a little heavy, and that's why I plan to do more podcasts on this. But it's so important because we're talking about diseases that start 5 to 10 years before they become a diagnosable problem. Breast cancer doesn't occur just overnight. It's probably 5 years in the making. Other diseases, Parkinson's and what have you, don't occur just out of the blue. They come because it is a cellular disease. The cells are not functioning properly. They do not absorb oxygen nor get rid of toxins as easily as they should because they have been made toxic by the oxidized, adulterated linoleic acid. And our aging is important with, I guess what I want to say is that as we age, we have to have a strong cellular functioning because it involves our muscles, our bones, and inflammation. Aging is, believe it or not, and when you age strong, it's not luck. It's biology, and that we can influence that by keeping ourselves strong. We have to always look beneath the symptoms, look for the root cause of the diseases and beyond the lab numbers. And we have to look where health actually begins. And that's the cell membrane. The cell membrane, as Professor Peskins has said, that is the brain of the cell. We have to look at the mitochondria and the biochemical signals that determine whether tissue repair or whether we slowly decline. It's a whole new paradigm, but I think it's the right one. Keep our cells healthy, and we can grow old and be healthy because we cannot. Growing old is inevitable, right? But growing fragile is not. And the difference is in the health of your cells. So with that, I'm going to pause for today. And Martin, I just saw a question. I just got back here. Martin, to be honest with you, I'm a charter member of the American College of Emergency Physicians. I am a lifetime fellow of the American Academy of Family Practice, board certified in pain management and acupuncture, and a list of other things. So I practiced primary care and pain management and holistic health during my active career. And now I'm just trying to share some of my 60 years of experience and talking to professionals in the field who have studied this. And sometimes you don't hear about them because they go against the pharmaceutical companies. And pharmaceutical companies sponsor a lot of research, and you have to give them what they're paying for. And a lot of physicians today are employed and they have to follow guidelines and protocols. So I want to get, to use a term, I want to make medicine great again, have physicians think and analyze and critically think about problems and remember their biology and physiology. Too often we forget about that and we just have a diagnosis and we label somebody and then we follow that protocol and we don't think about other actions that could be taken. So I hope that answers your question. Martin, thanks for asking that, by the way. And subscribe to my Substack. I think you'll see some interesting articles there. And with that, let's call it a day, and everybody be well. God bless. See you next week.
Hey everybody, Dr. Ron's finished for today. I hope you got some good wisdom for what the man had to say. If it's all about good health, he's the man you got to see. He has a lot more answers for you. So tune in next week when the doctor is in the house. Or when the doctor is in the house. And let the doctor know what's bothering you. When the doctor is in the house. The doctor is in the house. The doctor is in the house. And let the doctor know what's bothering you. I'm sure he can tell you just what to do. The doctor is in the house. The doctor is in the house. Let the doctor know what's bothering you. When the doctor is in the house. So if you have a pain, call the doctor. If you have a strain, call the doctor. Let the doctor know what's bothering you. When the doctor is in the house.